So we need to, now this symbol, this sigma symbol, simply means to add them all together. And let's see, statistical, and then of course they nicely show that to you here. Yeah. So we just add them all together. So let's work this through. There is actually a function in Excel that will automatically calculate the mean and the standard deviation, but I like for us to do it on our own first. So we need to, we're going to work with the subtraction. So we need to sum all those values. So we're going to say first the sum of the L's equals, and that, since it's a text box, it won't make a formula. So that's just a label for me. Now I'm going to go to the box to the right of it. And I'm going to say equals sum. Notice how it starts popping up suggestions. I wonder if it actually, if I click on it, I thought it would give me help. All right. So I want to sum them, and then I want to open parentheses, and I'm going to choose all these numbers. And then I'm going to close the parentheses. And I'm going to hit enter. So that's the sum of all those guys. Would you, anybody like me to do that again?
Yeah, please.
Of course, don't worry, don't worry. Look guys, there was this, I remember at Brookhaven National Lab one day, every Tuesday we would go down to a break room, and there was a kind of lounge area outside of the lecture hall in the physics department, and we'd have the department tea. So we'd have tea and coffee and cookies, and you can watch many socially inept people trying to make small talk, but of course they were among other socially inept people. So it could be interesting. And I remember there was this guy there one day, and he's a world famous dude named Maurice Goldhaber. And I just happened to listen, and he said a couple of interesting things. And one of them was that, and other people say it too, but he said, everything is simple when you know the answer. So you should never be embarrassed when you don't know something, or especially when you're first learning it, okay? Everything is simple when you know the answers. You shouldn't just say, well, I know this must be obvious, but I don't know what's going on here, right? It's just something you have to train yourself. Okay, so I'm going to undo that. So again, I wrote myself, this is just for humans. This, I'm saying this is the sum of the L's. So in other words, you see this sigma x sub I? That's, and in the particular case, the x sub I are these different L2 minus L1s. So the sum of the L's. So if you want the sum of L2 minus L1, the sum of the L2 minus L1s. There we go. Nothing like making it obvious, guys, because, you know, in a week from now, you want to be able to pull this back up and know what you were doing. So now I go to here into the right. So now I want a number there, right? So I want to sum them. So you type equal. Excuse me. Now, guys, I don't expect you to be writing down all these steps that we're doing. You might make a few notes to yourself, but I want you to focus on what we're doing here. So now I type sum, open parentheses, and now I click and hold the left mouse button down, and I pull it down to all the numbers. Now I let go of the mouse button. Now I close the parentheses. I mean, if you don't, look, I'll get rid of that. If I try to hit enter, oh, it didn't complain. I'm surprised. Oh, it filled in the parentheses automatically. Isn't that interesting? All right, cool. It has some idiot-proofedness to it, huh? So equals sum, open parentheses, select here, close. And now I need to know how many there are, right? Well, there's a couple things I can do. 1, 2, 3. Now watch this. This is kind of cool. I typed in 1, 2, 3. I select all 3. I grab the fill handle. Isn't that interesting? It kind of tries to guess what I'm trying to do. You could do something like this. 2, 4. Let's see. Very useful feature. So you know what? I want to see now. So in this case, we know that n equals 10, but there's got to be a function to count the number equals num nu. No, that's interesting. I don't know the function for this. Let's see. We want to know. That's funny. I have a tendency, like, I could just use this number column I made, and I know n equals 10, right? Number of entries. Let's see what that gets us. No, the count function. Counts the number of cells that contain numbers. Okay, let's see what happens. Equals count. This is how you learn how to use a spreadsheet, guys. You realize that something I'm doing is dumb and or it's taking too long. And look at that. So I know there's 10 entries, and so that function got me what I wanted. Okay, so now we look and we've got our sum and we've got our n. So then that means that the average value, whoops. Well, I want to leave room here. Average L2 minus L1 equals, whoops. I want to put a space in there. Okay, so that's going to equal the sum divided by the number of entries. And look at that.
you redo that again?
Of course.
All right.
Okay, so I've got the sum of all these guys, right? See that?
Yeah.
Then I can either just create this marker, or they call this like an index. And notice that's what this is too, this I over here. That's called an index or a subscript. So I can count the number of members in my table this way, and which is fine for a small table. But, and also, you took 10 measurements, but maybe you have a bunch of measurements, you're not sure. So I looked up and I found this function called count. So I said equals, and then I started typing COUNT. Oh, it works. And then I open parentheses. I select the counting. I want to count how many entries there are. There's 10. So that's my capital N, right? So I noticed that it's 1 over n times the sum. So that's the same as saying the sum equals the sum, which is this number, and dividing by capital N. Making sense?
Makes sense.
Oh, good. I like it when I make sense. All right. See, by the end of the semester, you're going to be Excel whizzes. Definitely got to figure out a way to work this in when we're in in-person classes. Right, so now let's go ahead. And so we need to do that for the width, right? Sum of W2, oops, yeah, W2 minus W1s. And somehow, oh yeah, W's are wider than L's. That's why I was wondering why it's taking up more space. Equals. So there's a case where I'd like to make this a little wider. Okay. Oh yeah, here's another trick. Watch this. So I select those. I go up to alignment, and now they're aligned to the right. Looks neater, right? Let's see if this looks nice. I'm not sure. Yeah, maybe. It's up to you. And then N equals, and then the average of W2 minus W1 equals, and we just do it again, equals sum, open parentheses, close parentheses, equals count, oops, open parentheses, select, close parentheses. Oh yeah, by the way, I mean, it's not as critical to you guys as it was when I was your age, but they used to always say the #1 rule of computing is to save early and save often. So always make sure to save once in a while. If you're using Google Sheets, it saves automatically. Somebody's buzzing me here. What's going on? Oh, okay. Somebody got punted. Wow, it's already 3:28, isn't it?
Yes,
Maybe
sir.
I
Can you
lied.
show me how to do the sum of the W2 minus W1 again,
Let
please?
me. Sorry, Brenda. Try again.
Can you show me how you did the sum?
Oh, sure. So of course I've done the W2 minus W1, right? They're all here. So then I go here and I say equal sum, open parentheses. I select the ten numbers, the 10 differences. Then I close the parentheses. Then I hit enter.
Okay, thank you.
You're welcome. Yeah, don't be afraid. And now the average, of course, is once again going to be equal to, excuse me, the sum divided by n. And there it is. So now we have our two, averages, or if we want to use the fancy word, the means, the two means. So we can also get fancy once again.
Professor,
Sir.
on the pre-lab, there's like a, is that theta or not theta? There's like an O and then length and O and
Yeah,
length.
yeah, sure,
Is that
sure.
the average?
Yeah, the mean and the standard deviation.
Oh, standard deviation.
Yeah, so this kind of brackets is another way to do average. There's a couple ways to say average. Give me a minute. I'm looking for my notes. Where'd it go? Ah, here we go. That's a good question. Tablet. Okay. So you have, so that's a way. This is not actually the most popular. Another way to do it would be to say the length with a bar on top. Anytime you put a bar, that means average. And then there's also this one, the mu, and then you might put L, or in fact, I guess a little L, because that's what we want to be consistent. Mu sub L or mu sub length. As I tell my lecture kids, you can define it any way you want. Using right. Okay. Let's go into it. When you express the standard deviation, let's see if I can get this right. Sigma of x minus mu over n. I know there's got to be a square root in there. Oh yeah, so it's yeah, that's called the variation. Sigma squared is the variation, so we're taking the square root to get the square root of the variation. I'm not sure that question, Nicholas. Just hold on a minute. Oh, I understand. Right. That's a great question, Nicholas. I'm not sure, actually. That's one of the reasons why we're doing this out explicitly instead of using the built-in functions. Yeah, anytime you use a spreadsheet, you have to carefully make sure that if you're going to use one of the built-in functions, you've got to make sure that it's doing exactly what you expect. So it's always a good idea to build up these formulas by hand first. Now, that's a very good question. Okay, so what this is called the standard deviation of the distribution. So what this means is that you have an infinite number of entries, or you have a huge number, infinite or huge, which is not a very precise term. So you may have heard things like the average height of an American male is 5'10", plus or minus a certain amount. So yeah, so infinite or huge. It means that when you have a distribution, if you know you have every single member, so you've measured every single man in the United States, then this sigma is the actual standard deviation. Oh, right, Emmanuel, hold on to that one. So we'll talk about that when we get to it. So when you know you have measured every single member of a group, then that's what you use. With n-1, I can't remember. So what we actually do in the real world is we do sigma of our measurements. Now, this is, and I know that sigma of measurements like this is basically, I think these formulas are only for Gaussians too. I gotta double check that one. Oops. Get that little square under here. So if you think about it for a minute, first of all, you're making the denominators a little bit smaller. So sigma of your measurements is going to be greater than the standard deviation of everybody. Standard deviation of all members, right? So what that's saying is that you're acknowledging that you're not sure if you're sampling enough, you've done enough measurements that you're guaranteed that you actually know that you have a Gaussian. So there's no really strict definition of this. And if you look, I have an article, I don't know if I posted it for you guys, about error analysis detailed, and it's really some heavy math behind this. So when you know because Mother Nature has blessed us with the central limit theorem, we can basically, we feel comfortable with n-1 because if you have 10 measurements, and now you're dividing by 9. The difference between dividing by 9 and 10 isn't very much, right? If you have 100 measurements, then you have the difference between dividing by 100 or 99, and that difference is just about nothing. And remember I said earlier that in the central limit theorem, it turns out that you only need, gosh, I think the lower limit is, it might even be only 6 or 7. Let me see. Sampling normal distribution. I mean, this is what my whole professional career has been, probability and statistics, because of you do millions and millions of collisions. How many number of measurements? What is a normal sample? How do you know if a norm is normally distributed? Yeah, there's tests you can do. Things like called the kurtosis. That's another How many sampling just given? Suppose that we mean content confidence level. Oh well, I forget the right sampling, normal distribution, number of measurements. Number of measurements. Oops. Yeah, here is sample versus. Oh boy, I'm not going to get into that. So this is the standard deviation of your sample, if you will. Okay. So when you do the when you do a sigma, when you quote a sigma, you should always say to the reader, I use the, because you could say like, because it is well known with a reference, like a little footnote, that this measurement follows the normal distribution, we decided to use n. Or because we have a little bit of doubt that we have a parent distribution is normal, we're going to use n minus 1. It's really deep stuff to explain it, and I hope I didn't get too confusing. Yeah, it's all about just because you're acknowledging you're acknowledging to people that it's not only is that you're just not 100% confident that you have a normal distribution. But because, of course, of the central limit theorem, we don't have to do n minus 2 or n minus 10. We can just do n minus 1. Okay. So now we need the standard deviation. So let's get that formula. And yeah, this is great. So manual tells us, and probably if we look at the help files, so this is the normal distribution. Oh, it doesn't even have the n minus 1. See, I didn't get into this last week. I just told you to do what it says here, because it's a simple matter to change 10 to 9 and double check what you did. But I didn't want to get it. This stuff I think is confusing enough. Okay, snipping tool, new. Oh boy, my living room always turns into a solar oven. I should have closed up the shades before we get started. Okay, paste. So we have to form first this sigma here of a particular value. Question? Okay, so we need to form this column. We need to make a column of numbers. And the column of numbers is going to be, copy, paste. Can I crop this? Yes. So we want, first of all, to make this column here. So watch what I'm going to do. I'm going to click here. I'm going to right mouse click. I'm going to hit insert. And notice I get another column. Okay. So this is going to be my, well, I'm just going to call it, let's see, data, just to save some time, data minus mean. Okay, so now we have our data. So wait a minute, sorry, equals first. The data minus, so the mean or the average is down here, huh? Now, Well, first of all, I'm just going to do this, and I'm going to show you what happens. We're not doing this completely correctly. So I hit that, and I got a number. So you think, well, I'll just drag it and fill it. And the thing with that is, though, it's not obvious, but these are not right. And you can see how these two are the same. Because if you look here, that's E20, huh? But this one is E21. And there's nothing in E21. So this is called relative addressing, and we need to do something about that. So watch this. First of all, I'm going to clear the contents. So we're going to say equals data minus the mean or the average, but before I hit enter, I'm going to hit the F4 function key, F4 function, one time. See the dollar signs? Now, if you're using Excel or Google Sheets, F4 may not work. So the other way to do it is to go equals data minus the average, hit enter, and then come back to it, click, click, double click, and now because the cursor is in the cell, I can just type in the dollar sign and the dollar sign. All right? So then I hit enter, and we double check, it's there. And now when I fill it, now I get a spread of numbers, plus and minus. And we're going to come back to this too when we do curve fitting. This is all intertwined. It's really cool stuff. So, but you notice we got this pesky little squared symbol, so we're not quite done. And I'll come back. I need to insert another column. And so now I need data minus mean, and I need it squared. And so what I'm going to do is I'm just going to make that font a little smaller so it fits. And then I'm just going to say equals this, and I use Shift 6, this little caret symbol, squared, or you can simply do this, G5 times G5 again, and there it is squared, and I fill it in. So, would anybody like me to do that all again?
Yes, please.
Could you do
one
that
more
again?
time.
My pleasure. Okay, first we want is what's inside the parentheses here. The data point minus the average of the data points. So equals the data point minus the average of the data points. Now I think, oh yeah, look at this. Just take your, click inside of here, and then you can do dollar sign dollar sign. That's absolute addressing. So it always refers to the same box. Okay. So then we hit enter. Excuse me. And then we can use the fill handle. And we can double check. Yep. F6 minus the average. F7 minus the average. And so on. So now we've got X, the data point minus the average, but we also now have to square it. So I say equals this, and I want to raise it to the squared second power, which is the same thing as saying I'm squaring it. And that little caret thing is should be over the 6 key. So I do Shift 6, enter, and you can see 3.1 times 3.1 is close to 10. And then I drag and fill once again. And I can now add some grid. How we doing? One more time?
Can you do the last part one more time, please?
Of course. So you notice that we have this formula. Of course, here's the main formula, and we're building up the parts, right? So I want to build up this part first. And in fact, so I see inside the parentheses, X sub I, these are the X sub I's, the data points, the measurements. So I need a data point minus the average. So for every data point, I have to do data minus the average, and here it is. And now I also see that I have to square them. Now I could have done it in one step, but I'm doing it in 2 steps. So I say equal, and one of the reasons to do this, guys, is because Excel forces you to type out complicated formulas on a single line. So it can get really difficult to debug. And that's why there's an advantage, not just because I'm teaching it to you the first time, but there's an advantage to making separate pieces like this because it becomes easier to debug. And that's the problem with spreadsheets, that they don't scale up very easily when it comes to data analysis. All right, so now we need to square the data minus the mean. So then I'm going to use this caret symbol, which is over the 6 key, Shift 6. Maybe I can show you that here. Let's see. Right. So, wow, it doesn't come across very well, does it? Oh, it's upside down. Okay. There it is right there, huh? See that over the 6? So you hold down the Shift key and you hit the 6 and you'll get that little caret symbol, a little up hat symbol. And to excel in a formula, that means raise it to the power. In fact, we use it in when we write it by hand, in fact. Let's see, I'm going to put this like so, I suppose. And so there is the little caret thing, and I want to square it, and there it is. So then I fill it in. Okay, how's that? Is it making any sense? So the next thing we need is to, let's see, I want to copy and I want to paste. So the next thing I have to formulate is the sum of all those guys. So this was the first thing we did, and we did it in 2 steps. Whoops. Oh. And so that's this one. And copy and paste. So first we did this, then we did the square. Now we have to do the sum of these guys. So we have here, this is going to be the sum of the sum of data minus fit squared equals. So that's going to equal sum of these guys. And hit enter. Now we can do the final one in one step. So we call this the let's see, let's call this the standard deviation of what should we call this? Everything, yeah. Standard deviation overall. I can't think of a good word. It's the standard deviation of infinity, huh? I don't know. I should have thought of that one. Because ultimately we want n over 1. So this is, we have to take this guy divided by n and then do the square root. Okay, so now you're going to see why it can get a little dicey. So we want to say open parentheses, the sum divided by n, and then I want to take the square root of it, so then I just raise it to the half power. So that one probably made your head spin a little bit. So you see E21 is this quantity right here. Wow. Well, here we go. So this is here. And now I want to create this beast right here. So E21 is the sum of the squares. And then I need to divide it by n, which is E19. And then I have to take the square root, which is the same thing as raising it to the half power. Excuse me. How we doing, guys?
All right.
Good. It's a lot to take in. And it saddens me that this is like you guys have never seen this before. Well, that's all right though, because you're going to walk out of my lab class and you're going to be ahead of your classmates. Remember, I told you, you may do a little more work than some of your classmates in my lab, but everything we do is very, very useful. So the only thing now is we want the standard deviation of our sample. And for that, we need to have it divided by n minus 1. So let's see, we have to be a little careful. We can't just drag this down. We have to start over again. Equals, open parentheses, of, now it's the sum, this guy, divided by, and now I got to open parentheses again, and that's going to be n minus 1, close parentheses, close parentheses again, raise it to the 0.5 power. And you see, it got a little bigger, not a lot. Oh, what happened? Oh, I know what I did. I didn't,
Professor, can you show us how to do the sum of the dA minus Fi
Sure,
to the second power?
sure. Okay, so you see how it did get a little bigger. Oh, that's not what I want. I want the borders. Oh yeah, let's save. All right. Okay, so right. So we constructed the data minus the average, keeping in mind we needed to use these dollar signs. So I'm assuming everybody's gotten this far. And now we need to add the square. So we basically just taking this number and squaring it. And so there's another way we can do it. We can just do times itself, right? G5 times G5 is the same thing as G5 squared. And then we just fill it in. So is there, sorry?
I was asking how to do the sum of the dA minus Fi.
Oh, the lower, I'm sorry. Okay. So now, let's just, wait a minute. Let's clear the contents. So these numbers are going to go away. So we do equals sum of the data minus the, oh, what does Fi stand for? Data minus, oh, that's funny. I did, okay. Data minus fit, You'll see why I did that soon. I got to change that. And close the parentheses. So this is data minus average. Sorry. Or mean. Let's put mean there because I put it. All right. Let's do this. Let's make it all consistent. ABG average. ABG. Now it's all consistent. Okay. All right. Does it make more sense now?
Yes.
Thank you. Good. Okay. So, gosh, look at how long we've taken. So let me see the lab write-up, the manual, and did you get the C? Cost per or vice. And you, okay. You getting trend line. Okay, so we can't do question 3. Ah, I see. There was some kind of exercise. Ah, so this, here's a good one. This is an open-ended question. You can do question 4, but that's like, don't worry about getting it right or wrong, because this is what we're going to do next week. But think about it. Okay, so you can do questions 1, 2, and 4. All right, make a note to yourselves. New slide. Questions 1, 2, 4 at end of manual. And then question 4 is the is actually what we're going to be learning how to do next week. And I'd like you to guess at how we might do the error propagation. So it's asking you, you have a length measurement and you have a width measurement and you have a plus minus. What is, how would you assign an error to the area? So you multiply length times width. So let's recap here for a minute. So what we've determined is that the length of my block, anyway, is 13.83 centimeters, I believe. Yeah. Plus or minus, well, let's write this out because that's where scientific notation can get you in trouble. So I am just simply going to do this. No, that didn't work very well, did it? So in other words, this is, that's not the average value, Harry. You gotta be careful. So this is 0.138 meters, so that's 13.83 centimeters. And this is plus minus that's millimeters, so it's 0.17 centimeters. You found the problem. Oh, okay. So it doesn't, you have to add this little hash mark. Okay. So that's, at the end of the day, this is what we've determined. So we're saying it's plus or minus 1.7 millimeters. So let's see. So I'm going to leave the rest of this to you guys. So here's what on top of the questions, and of course you can ask for help, but I'm starting to burn out here. Okay, so for let's see, it's analysis and results. Analysis and results. This is just referring to the format. So you have the questions, of course. So finish the spreadsheet. That doesn't look right. Finish the spreadsheet. And try to make it look nice. Try to make it look nice and neat, or embellish it any way you like. Some people like to add colors, but remember, it needs to be easily readable. I've had people add all kinds of crap, and it becomes hard to read. Whoops. No.
Just a quick question. So
Sure.
The Excel tables that we made, do we print that out and then glue it to our notebooks, or do we just?
But I can't talk fast enough for you, huh? Well, look, if you can print, yes, it would be real neat to print these out. And so I think you just do this and you say print. Ooh, what about print active, print selection? There it is. Neat, huh? I don't know how many, not all of us have printers available, but it would be great. If you can't, yeah, that's right. What I would suggest is, wait, let me stay on track. Finish the spreadsheet, do all the other, calculate your, standard deviations and all that. Yes, if possible, print and paste. Remember the rules in notebooks about doing your date, time, or your date and initials. Make sure it's inside those blue lines. If you don't have a printer, I would say leave some space in your logbook until you get access to a printer, so you can paste it in later. But then when you do your Adobe scan, how would we do this? Just use Adobe scan and take a picture of your screen so I see your spreadsheet. I mean, you can get fancy, and if you know how to take a PDF from Adobe scan and add like a PDF from the spreadsheet, but just take Adobe scan and take a picture of your screen of the spreadsheet, so I see that you did the work. And then, of course, in the meantime, if you need help, you could send me your spreadsheet, or I can look over your shoulder. Oh boy, I'm sorry. It's gotten really hot in my room here, and I'm kind of losing it. Let's make sure I covered it. Oh yeah, let's Emmanuel. We need to check. I want to see this. I never thought of it before. Where is the spreadsheet? Here it is. So we want to know standard deviation, right? So that means that's the data points, right? So let's try this. So we want to see Excel standard deviation. Okay. I'm interested in this. Equals ST. So there's different kinds. Standard deviation P, standard D. Yeah, the recordings posted. Yes, I'll get them if I think I have been. I see. So standard deviation, the old style are not available anymore. So we need to find out. Okay. So we'll go up here. So you can click on this F here. And let's see, S, T, D, no, which is, yeah, I know, I'm looking that up right now, Nicholas. Yeah, oh, the standard infin, that's the one with just an N on the bottom. And then the standard deviation is with N-1. And did I put that in the notes? Let's double check. Yeah, here it is. So this is, yeah, see, that's where I got infin from. Here's the stylus. Come on. Oh, sometimes it's fighting me for some reason. Oh, it's on. Here we go. This is STDDEVINFIN. And then this is the standard deviation of the sample. STDDEV, and we called it measurement. Okay. That's a great question. And that's with the N-1, Ruben. Save it. Okay. Come on. So we need to examine, see, this is how, so what did I do here? I went up here to the formula bar and I clicked on insert function. So then standard deviation, and I hit go. So let's see. So standard deviation of a sample is for combat. No, we don't care. Standard. That's deprecated. That's only S. Estimate based on a sample. Ignores what? Oh, okay. So that's the standard deviation P, which I don't know where the P comes from, but that's the standard deviation of infinity. Ooh, let's try it then. We can compare both of them, huh? So first of all, we want to do standard deviation S, I guess, which means sample. Okay. And then, oh, I don't want to do this. So equals standard S, STDEV dot S. So that is this. So now I'm just selecting the data points. Ooh, so that, look at that. Holy smoke, huh? Format cells, scientific. So there it is, standard deviation of STDEV.S. And so that's standard deviation of sample. Okay, I put measurements before. Oh boy. Instead, I'm burning out. Sorry, guys. So we want Excel EL STDDEV infin. And so that's supposed to be equals STDEV dot P. See, I learned something today. And there it is, coolio, huh? So from now on, since we've gone through all this pain, you guys can just use these functions. You just have to make sure. Oh, I don't know if we're ever going to calculate another standard deviation. How is that in Excel?